So we are to take the graph y equals 8 minus 8x squared along with the graph x equals minus 1, x equals 1, and y equals 0. Find the region bounded by those graphs and then rotate it about the x-axis. So the graph y equals 8 minus 8x squared is just going to be a parabola that opens down and has a vertex at 0, 8. Then if we were to bound that by x equals minus 1 and 1 and y equals 0, which is the x-axis, then we would have this shaded region here. Now if we rotate that about the x-axis, then we would wind up with another part of it down here if we're just looking at it in 2 dimensions. And if we were to take a representative width here inside this region and then rotate it around the x-axis and then draw the disk, we'd have something like this with a face on the front, and the radius of that thing would just be whatever the y value is for any given x value when y is given by 8 minus 8x squared. So the radius then is just going to be 8 minus 8x squared. And then, so all we're going to do then is to find the volume of a disk like this, we would take the area of the face, which is going to be pi r squared, or pi times 8 minus 8x squared, and then multiply that by the thickness, which is our dx. Then if we were to chop that up into infinitely many pieces, then we could find the volume of the entire object by integrating from minus 1 to 1 that area times that thickness. In order to do that, we would probably need to go ahead and multiply out 8 minus 8x squared, which would give us 64 minus 128x squared plus 64x to the fourth. We can pull the pi out front because it's constant, because our variable of integration is x. And then integrating each one of these terms, we'd have 64x minus 128x cubed plus 64x to the fifth over 5, and then we would evaluate that from minus 1 to 1. Because this region is symmetric on either side, those terms should match up. We really could have integrated from 0 to 1 and then multiplied it by 2. So now substituting, first we'll substitute 1 in for x, and we'll wind up with 64 minus 128 thirds plus 64 fifths. And then we're going to subtract then the substitution of negative 1 in for x. So we'll have 64 times negative 1 minus 128 times minus 1 cubed, which will still be minus 1 over 3, plus 64 times, and this will be minus 1 to the fifth over 5, which will still be minus 1 then. And then removing these parentheses here, all that's going to happen is we're going to distribute that negative, and we're going to wind up with minus 1 and a minus 1, giving us a positive 64. And then 1, 2, 3 negatives, giving us a negative 128 over 3. And then 1, 2 negatives, giving us a positive 64 fifths. And something to note is that, so we have these matching terms here. 64 plus 64 will be 128. Minus 128 thirds minus 128 thirds will give us minus 256 thirds. 64 fifths plus 64 fifths will give us 128 fifths. And then we need a common denominator, which will be 15. And multiplying 128 by 15, we'll get 1920. Multiplying by 256 by 5, we'll get 1280. Multiplying 128 by 3, we'll get 384. adding the terms and then multiplying by pi, and we're going to get 1024 pi over 15.